Alright, this is part 4 of our review of radical functions. In this video, we're going to go back to graphing radical functions, such as these. Alright, for number 21, there's nothing in front of the x in here, so I don't need to start with the y values like I sometimes have to. Also, there's no a value, so I don't need a third column. So what I can do is I can go ahead and use the same four x values that I often use. 0, 1, 4, and 9. Alright, because I'm going to get the y values by simply doing the square root of x part of this function. I'm just doing this part. Alright, we'll do the shifting by hand. Alright, so of course when I do the square root of the x values, I get 0, 1, 2, and 3. So let's go ahead and graph these points, but do not connect the dots. We'll leave it as a skeleton. Why did I skip a square? I don't know. So it's 0, 0, 1, 1, 4, 2, and 9, 3. Alright, so, but now it's time to do those transformations. That's weird. So the transformations are, this -1 is going to take us to the right 1, and this +2 is going to take us up 2. So right 1, up 2. So let's move. Why is this shifting around? Alright, so this is the skeleton right here. So each of these points need to be moved right 1 and up 2. Normally I would change colors, but for some reason every time I change colors, everything moves to the wrong place. So right 1 up 2 would be right here, and then right here, and here, and here. So this is the true graph. Alright, so that's how you graph it. Now let's answer these questions. The starting point is this 1, 2. Alright, is it increasing or decreasing? Well, it's going uphill the entire way from left to right, so that's increasing. The domain is the x values. The x values go from 1 to infinity. Alright, and that needs to be a square bracket. The range, that's the y values. The y values go from 2 to infinity. Alright, is there an absolute max or an absolute min? There is no absolute max because it keeps going up forever. But the absolute min, the lowest value is 2. Okay, so the absolute min is 2, and absolute max, there is none. What about the end behavior? Okay, as x approaches negative infinity, meaning as we go to the left, what happens to the y values? Well, the y values get closer and closer to this end point, which is at 2. So f of x approaches 2. Now, as x approaches positive infinity, that means as we go towards the right, what happens to the y values? Well, they go up, up, up into the sky. So that means f of x approaches infinity. So that is it for problem number 21. Alright, number 22 will be a little bit more challenging because it's got this reflection over the y-axis happening. Whenever we see that, we know that we actually have to start with the y values instead of the x values. Alright, so as we saw on the previous problem, The y values that we like, hold on, let me make sure this is a square root. Alright, yeah, this is a square root function just like number 21. So the y values that we usually get are 0, 1, 2, and 3. Now we want to get those same y values no matter what. So let's go ahead and put them down. 0, 1, 2, 3. That's what we want. Now, to get those y values, please understand that instead of just having the square root of x, now we have the square root of negative x. So we have to deal with that. So we have the square root of negative x. So we need to figure out which x values it will take to get us the y values that we want. So, for example, well, obviously if I want to get 0, I still need 0. So, say if I want a y value of 1, then that means that the square root of negative x has to equal 1. So I would have to square both sides to solve this. So that would give me negative x equals 1. And then I would divide both sides by negative 1. So I'd get x equals negative 1. Now, if I wanted a y value of 2, then that means the square root of negative x has to equal 2. So to solve this, I square both sides. I get negative x equals 4. I divide both sides by negative 1, and I get x equals negative 4. And finally, if I want a y value of 3, that means the square root of negative x has to equal 3. Squaring both sides, I get negative x equals 9. Dividing by negative 1, I get x equals negative 9. So these are the x values that I need. So I had to work backwards. Do we need a third column on this one? We do, because we have this a value right here. So I need a third column. I can't erase this because if I do, for some reason the graph will move. I don't know why. So I'm going to just squeeze in my third column right here. Okay, you get the third column by multiplying by the a value, which is 2. Alright, so I'm just going to multiply everything times 2. So that's going to give me 0 and 2 and 4 and 6. Okay, so now once you have that, you can forget about the middle column. So we're going to start off with our 0, 0, negative 1, 2, negative 4, 4, and negative 9, 6. Alright, that's not the final answer yet though, because we have not done the shifting yet. So this positive 1 means left 1. And this negative 1 on the end means down 1. So we have to move everything left 1 and down 1. Alright, so starting from here, if I go left 1, down 1, left 1, down 1, left 1, down 1, and left 1, down 1. So this is the true graph. Okay, so let's answer these questions. What's the starting point? Well, it's negative 1, negative 1. Is it increasing or decreasing? Well, from left to right, this entire thing is downhill. So that is decreasing. What about the domain? Domain is x values. The x values go from negative infinity to negative 1. What about the range? The range is y values. The y values go from negative 1 to infinity. Is there an absolute max or an absolute min? There's no absolute max because it goes up forever. But the absolute min is -1. That's the lowest y value. End behavior. As x approaches -infinity, meaning as we go to the left, what happens to the y values? They go up, up, up. So that means f of x approaches infinity. Alright, what about as x approaches infinity? That means as we go to the right. Now as we go to the right, the y values get closer and closer and closer to this end point. So that means the y values get closer and closer to -1. So f of x approaches -1. Okay, so that is it for problem number 22. Alright, for number 23, we're supposed to write the equation of the radical with domain from 1 to infinity and a range of 7 to infinity. Okay, so if you picture a normal, x and y axis, okay, usually a square root function will do like this. But in this case, the domain is supposed to be from 1 to infinity. So that means it has to start off to the right by 1. And the range, alright, because domain is x value, so it has to go over 1 on the x-axis. The range has to start off at 7. So let's see, 1, 2, 3, 4, 5, 6, 7. Okay, so that means the starting point has to be way up here. And then it's going from there. Okay, so imagine that the starting point is here. It's over 1 to the right and up 7. Okay, so in fact, let me write that down. So if we know it's got to be right 1 and up 7. So as we go ahead and write that graph, that function, to go right 1, we need the square root of x minus 1. And to go up 7, I need a plus 7 on the end. So this would be the answer to number 23. Alright, 24 is another graphing problem. Oh goody. So, and it's a complicated one. So we have a lot going on here. Again, we have a reflection over the y-axis. That means we're going to have to start with the y values and work our way backward. Okay, now notice that this is a cube root function. So normally, for a cube root function, we like to use x values of -8, -1, 0, 1, and 8. And then normally we go ahead and take the cube root of those x's. So that will give us -2, -1, 0, 1, and 2. Now we still want to use these y values, but we're going to need different x values this time. The reason why is because this negative right here on the inside, we have to deal with that. So we don't have the cube root of x, we have the cube root of -x as our starting place. So we need to figure out what x values it will take to get these y values. So just make a bunch of little equations. I'm going to do it off to the side. So for example, if I want -2, that means this cube root of -x must equal -2. Well, to solve that, I'm going to have to cube both sides of the equation. Alright, and that's going to give me -x is equal to -8. But then I would have to divide both sides by -1, so that would give me x equals +8. Okay, if I want a y value of -1, I can set this equal to -1. So I would need to now cube both sides. So that would give me -x is equal to -1. Dividing both sides by -1 gives me x equals +1. Now, of course, the only way to get 0 is with 0, and the rest of these are going to be the opposite of what we had up there. So since this is 1, we'll have -1. Since this is 8, we'll have -8. So these are the values, but wait, they're not the values, because is there an a value? Yes, there is. See, we got the -4 to deal with. That means we need a third column on this table. Alright, the third column is where we multiply all these y values by a. So I'm going to call it the AY column. And remember that a value is -4. So we're going to multiply everything by -4, all the y values. So that's going to give us +8 and +4 and 0 and -4 and -8. So once we have the third column, we can disregard the middle column. So these are the values that we have to graph as our skeleton function. 8, 8. So that'll be right here. And then 1, 4, 0, 0, -1, -4, and -8, -8. Alright, so the one thing we still haven't done yet is we haven't applied this shifting. So remember, this -1 right here is going to send us to the right 1. Okay, and this -2 on the end is going to send us down 2. So right 1, down 2. So let's take each one of these points and move right 1, down 2. Right 1, down 2. Right 1, down 2. Right 1, down 2. And right 1, down 2. So these are the true values that we need to graph. Alright, got a little squiggly there, but you get the idea. Alright, so your graph should look something like that. Now, let's answer these questions up here. Starting point, well, in the middle here at 1, -2, there's a point of inflection. I wouldn't really call that a starting point, so I'm just going to say none. Is it increasing or decreasing? From left to right, it's going uphill all the way. So that is increasing. The domain. Well, for these cube root functions, the domain and range will always be -infinity to +infinity. Because they go left forever, right forever, down forever, and up forever. That's a lot of forever. So domain is -infinity to +infinity. And the range is also -infinity to +infinity. Is there an absolute max or an absolute min? No. Alright, it goes forever in all directions, so there's no limit. End behavior. As x approaches -infinity, that means as we go to the left, what happens to the y values? Well, as we go to the left, the y values are going down, down, down. So that's why f of x approaches -infinity. Okay, as x approaches +infinity. In other words, as we go to the right, what happens to the y values? As we go to the right, the y values go up, up, up. So that's why we'll say f of x approaches positive infinity. Alright, so that is it for problem number 24. Alright, that's long enough for one video, so I'm going to stop this video here, and we still have a few more problems left, but I'll save that for one last video.